And when d is of this type, then we can use a generalization of the Fubini's theorem to rewrite the double integral in the form of two iterated integrals. If d is of the type 1, then we can rewrite this integral as two integrals of the function fxy. And now x runs from a to b. So this will be the outer integral of the space here. And for each x between a and b, say this one, y runs from phi 1x, so this is the lower limit for y, and y runs up to phi 2 of x. So this is the upper limit for y. And if the integration domain is of the second type, then the integral of this function can be written as these two integrals. And now we integrate in the reverse order. Not dy dx, but dx dy. And y runs from c up to d, and for each y between c and d, say this one, x starts at psi 1 of y and x goes up to psi 2 of y. And in this way, we can transform the double integral into two nested or iterated integrals, and then we can hope to find the antiderivative and to evaluate the integrals.